Alright, so now we're going to be looking at the concentration of a solution. We've already described a solution as being saturated, unsaturated, or supersaturated. So now we're going to look at concentration. How much solute is dissolved in a certain amount of solvent to make that solution. You've probably heard these terms before. If a solution has a lot of solute in it, we say that it is concentrated, and you can see that like this dark colored drink here. If a solution has just a little bit of solute in it, we say it is dilute or diluted. And here, like with the very light solution. You've probably, the most common place you've seen this is with orange juice. A lot of times you'll go and buy orange juice, and if you pick up the container, it says not from concentrate. That means they picked the oranges, made the juice, put it in the bottle, shipped it to you. Yay. But sometimes they will concentrate it, meaning they'll pick the oranges, make the juice, and extract a ton of the water out of it and make a very concentrated orange juice. They can freeze it in these containers, then they can sell it that way. And if you want to make orange juice, you thaw that container and then you dump what's inside there into a pitcher, and it's very, very thick. If you taste it, your salivary glands squeeze and you feel that pain like when you're eating Sour Patch Kids, because the saliva is trying to dilute the sourness in your mouth. And then you add the stuff that we're going to dilute it with. And we pretty much are most familiar with diluting with water. In theory, anytime you want to dilute a solution, you dilute with solvent. But since we're always talking about using water as our solvent, we will dilute with the water. So that's a very qualitative way to describe concentration. Something's concentrated, a lot of solute, not a lot of solute, it's dilute. Of course, though, we want to quantify that, and we can look at different quantitative ways that we can describe concentration. And some of them you'll be familiar with and see throughout your existence, like in the stores as consumers, such as percent solution. Hydrogen peroxide is sold in stores as a 3% solution. We've mentioned hydrogen peroxide earlier in the year. It's in a brown bottle because light can decompose it. So when you buy that solution, 3% of it is hydrogen peroxide, H2O2. And then the rest, 97%, is water. If you go into nursing or the medical field, you'll probably have to do some calculations involving IVs. And if you have a saline drip, that's a sodium chloride IV solution, and it has a certain percent solution. As well as if there's a glucose drip, then you've got a certain percentage of glucose in the IV. And you might have to use that concentration, the percent solution, to figure out like if you inject the medicine and the drip rate and all that fun stuff, fun calculations. But again, a lot of things at the store you can see sold as percent solution. Another expression of concentration that you'll see, and we saw it in our video last week, is proof. Alcoholic beverages, back in the old days, you had to prove that there was enough alcohol in them, and they would light it on fire. If it caught on fire, the alcohol content was good. If it did not, then you were shortchanging the people. And so that's how that terminology has stuck around. But if you remember in that video, our good buddy Don Showalter, he said, I have a solution, it's liquor. And he showed us his Bacardi rum. And that Bacardi rum, he said, was 80 proof, which means 40% alcohol. Again, remember, the percentage of alcohol is half of the proof. So if I have a 100 proof liquor, it's 50% alcohol. Moonshine, like on that TV show, or when we saw in October Sky when they had to go to the cabin to get that for their rocket fuel, that is 200 proof. It's 100% alcohol. And then the rest is typically water. Not that you need a lecture on liquors, but your standard old school liquors, vodka, rum, gin, etc., is pretty much alcohol and water. And now you've got fancy flavored ones or colored ones or creamy ones and stuff like that, so there's different ingredients in there. But again, the proof reflects the alcohol percentage, and then the rest of the solution, mostly water, but could be some other stuff. Now if you're a homeowner later in life, or just even a renter, your water company usually sends out a drinking water report, and it expresses everything that was found in your drinking water as it was tested, and those are oftentimes expressed in parts per million or parts per billion. We use this concentration expression to talk about things that are in very small quantities, and that's good. We don't want a lot of stuff in our drinking water. So here we see, like for example, calcium. In this test of water, calcium is going to be expressed in parts per million. There's an acceptable range to be found, and the score here of 13 means that for every million water molecules, they found 13 calcium ions present. Alright. Chlorate, one of our polyatomic ions, this is being expressed in parts per billion. Again, there's an acceptable range, and then its score of 155 means for every billion water molecules, there was 155 chlorate ions found. So again, we don't want to use this concentration for anything except things that we find in very small quantities. And this is how we would calculate this. Here we see that a water test finds 36 milligrams of mercury in a 750 gram sample. What is that concentration in parts per million? Well, the important part of this equation is right here. We're comparing the solute to the solution, so we have to make sure that we compare it in the same unit, grams. But you can see in the problem I've got milligrams of mercury, grams of solution, which is good. We don't want a lot of solute present in these situations, so first thing we're going to have to do is change milligrams to grams, which, if you remember, there's 1,000, like 1,000 years in a millennium, 1,000 milligrams in a gram, so we divide the 36 by 1,000. Now we can use that, compare it to the solution, multiply by a million, parts per million. If we wanted parts per billion, we'd multiply by a billion. Parts per trillion, you got it, multiply by a trillion. But when we do this, we get a nice reasonable answer of 48 ppm, parts per million. So again, concentration, solutions can be concentrated or dilute. In the consumer world, you could see that as percent solution or proof, or, on your water test, parts per million, parts per billion. In chemistry, we're going to look at it through the wonderful eyes of the mole, molarity. So that's what's coming up next, and I'll talk to you then.